Hello, we're working with Eaton, and our project is saving storeroom stress from shenanigans to solution. This is our problem statement. So the storeroom at Eaton's manufacturing plant in Beaver is sending inaccurate kits to the production line in an untimely fashion. This is their current layout. So the larger rectangles that you see on the top of the layout are pallet racks, which you can see on the top right-hand picture. The smaller rectangles towards the bottom of the layout are wire racks, also seen to the right. On the very bottom of the image in the left-hand corner, you'll see their shipping and receiving area. To the right of that is their office, then their bathroom, and then the outbound to production is in the far right-hand corner. These are our goals for the project. So for the picking process, we want to develop a written set of procedures for picking kits, and this includes written jobs for the storeroom, and we want to create a kitting area for them. We also want to redesign the storeroom as a whole, which means we want to create a layout and create an organized system for them on the wire and pallet racks. And for the refill process, we want to establish a process for put away in the storeroom.
With this in mind, we chose to use the DMAIC process. So the first step of that is collecting data so that we can determine baselines and create a fishbone diagram. We then determined that we had to design a kitting area and parts for picking kits and then change the inventory layout. So a little bit about those deliverables. The first thing we did was create metrics. So the data we got from Eaton was more distributed. So we made a mean confidence interval for the number of kits picked per day per person. And then for pick accuracy, we did not have previous data. So through our surveys, we conducted a beta distribution and determined a mean pick accuracy of about 75. We then made a spreadsheet with over 1,400 permanent locations for the different items. We used a U-flow layout in conjunction with an ABC analysis that we made. So with the picking area at the center, we first had the heavy items close to the gantry, and then as you went farther away from that, it's the A movers, and then farther from that is the B movers, and then the C.
So this is the kitting area we designed. We wanted the shelves to act as a midway point between the pallet racks themselves and the kitting area. So these shelves are slidable, so somebody picking with a cart can bring them over to the shelves, drop it off, and then the kidder can turn around, grab the kit, and inspect it and send it out to the production line.
So here is our new picking carts with power, and there's also enough space for laptop, monitor, scanner, and kits.
Here is our process flow chart. Once the ticket comes in, if the item is available, then the picker would pick the item and scan card barcode and move to the next item. If it's not available, then the filler would email buyer about the stock out.
And here's our rectilinear movement analysis. It is 4,327 average feet travel per day for our new improved picking process. So compared to the previous one, we have 61 decrease in total movement to locations and 51 decrease in time spent moving to locations.
Thank you very much for watching our video.